Before we get started, let's go on a little journey. So this place, if you can't tell, is my garage. When I moved into this house last year, almost last year to the month actually, almost to the date too. This garage just ended up being a place where we could put all our furniture and moving stuff and then slowly divvy it up through the house and then do renovations on the house and bring the stuff out here. And it was just a storage location like most people's garages end up being. I've cleaned up majority of it over the winter here. There's still some stuff we have to get rid of and donate. But for the most part, it's empty. You're sitting on a giant thing of insulation. There's more insulation there. There's a table saw back there. There's a giant lift of drywall here. I'm straddling a bunch of 2x4s. Basically enough stuff to completely insulate and soundproof and drywall and run lighting, because there's 2 light bulbs in here and the window, which is the only thing I'm really getting light from. So we're going to put like 8 fixtures in here, change it over to LED lighting, run 220 power in here. Basically just make it a proper shop, shop 2.0 for me. So I have some space to work in and some space to grow with. There's just a limited amount of equipment I can currently get into the basement because I have to go through stairwells and downstairs, and I can't get some things that I would like to get down there. So I need a new location. But Canada, so like -40, so it has to be prepped for it. So it's a little bit more work than just hanging drywall and off to the races. But that's what we're doing next. It's going to go a lot quicker than it probably should, because I want to start using it. So I plan to basically jump on this pretty hard to kind of get it up to a running area while somehow having other time to do my machining and then sleeping and spending time with my wife and eating. But we'll figure it out. We'll balance it. Plenty of hours in a day. That's what's going on next. So for the lack of lighting in the garage, it is so nice to have a window. That's the one thing I miss, is being able to see the outside world. Also why I want to get that place running for the summer, because like we have short summers here and I want to enjoy as much sunshine on my body as I can. Moving on. So, there we go. Building these up, I'm doing a batch of bolts right now. Actually my biggest batch of bolts I've done to date. And I'm pretty comfortable with all the processes of making these, threading the tips, milling the slots, doing the threading, making all the parts. Everything is fairly easy. There's 2 areas that kind of always give me a little bit of trouble. That is engraving on the pocket clip and putting the little 256 size screw thread into the end cap here. Both of that work is in titanium, and titanium is just an unforgiving mistress. It just if you make a mistake, boom, tools explode. Like aluminum, brass, you can usually kind of dumb thumb your way through and not get your feeds or speeds perfect, and for the most part it works. Titanium, not so much. It's if you do it wrong, it breaks, and then you got to figure out what you did wrong. So on this one, you can see the engravings on this one are awesome. I mean, it hasn't been polished yet. You can still see the tooling marks on the surface. I usually polish these first to get a nice matte finish before they go tumbly. But this is a 1/32 inch engraving, which looks awesome. In the past, I've also done some in 1/16. What I'm talking about is the thickness of the tool. I'll show you the tool because it's cool. So this is a 1/32 inch stub end mill, and this is what I'm currently using to do the engraving on my pens. Actually, these are from Lakeshore Carbide. Very happy with them, actually. And in the past, I was using this size tool, but I was using it in a 4-flute fashion because my mill doesn't spin very fast. I only have like 2,400 RPM or whatever out of its stock. So typically, if you add flute count, you can increase the feed. However, Mr. John Grimsmo on Instagram basically sent me a comment and said, hey, try dropping down to a 2-flute because those other 2 flutes on a 4-flute are kind of just hanging around doing nothing at the depth we're cutting. Like I'm only cutting 3 thou deep to do engraving, between 3 and 5 thou to do the engraving work. So at that just small of a ball end mill, some of those flutes are just really doing nothing. So dropping down to a 2-flute, I don't know if it reduced my rubbing or what it did, but the engravings are coming out perfectly. I did a whole run of 20 pocket clips on one tool with no breaks, and all the engravings are crisp and clean, and I'm super happy with them. And it took me probably 1/10 the time to do it as I do normally because I always have to fiddle and change with offsets to try to get all the text nice and happy, but they just work so well. I'm completely pleased with it, which lets me increase my batches more. I'm knocking stuff everywhere. It lets me increase my batch size when I get more confident with my processes, so that's a win-win-win. So with a reliable recipe to do the engravings, that was basically one of the difficult tasks tackled. The last one was the 2/56 size tapped hole in the end here. So we got here. This is the cap in question. It's basically just a piece of titanium. These are threaded to go to the body. This little diamond is milled in it, and that takes the pocket clip. You can see on that one how it sits in there. And then in the center there's a little hole, and that's where the screw goes to hold the pocket clip in place. In the past, I'd been tapping that with basically just taps designed for titanium. They're like your standard 3-flute, but the rake geometry and what changes. They're actually 2-flute instead of 3 to get a little more structure out of it. It works. It worked okay. It's tedious every time I do it. I'd put it in the mill and I would basically turn them by hand and then have to back them off to break the chip. And then the whole time I'm at like 90% of what the tap can take. Like if I stress it too much or if I go too many turns without backing off, it snaps. If the hole isn't perfectly sized, it snaps. If anything is out of alignment, it snaps. Like there's no forgiveness. And I mean, they're not cheap taps. They're not expensive taps. But they're not cheap either. And that's one process I hate. I hate something that I can't scale, and that's something I couldn't scale because it was a slow part and it required a ton of manual work. So I looked for better options. So the better option I ended up coming across was form tapping. This is a form tap. Basically, what it is it's a tap with no flutes on it. If you want to think of it like a carbide screw, that's basically what it is. There's a slight woggle to it. The end, if you're facing it this way, is kind of either triangular or square. So when it spins, not all sides are contacting at once. Like 3 or 4 sides will be contacting the inner bore. And all it does is it basically just forces the metal out of the way. Not something I would have ever tried in titanium because titanium doesn't like to be rubbed. It likes to be cut and then don't touch it or else it work hardens. But a ton of very talented machinists in various forums or online had said if you're tapping smaller than 440, form taps are the way to go, even in grade 5 titanium. So I went ahead and I bought a bunch of them because I thought I'd be exploding a bunch. Tried one. and was absolutely amazed how well it cut. And then I did it again, and then did it again, and then did it again, and again, and again, and again. And I went through the whole run of pens I have with zero issue. All the way down, all the way back out, all under machine power. Amazing. It took a procedure that would typically take me 5, maybe even 10 minutes per cap down to 30 seconds. So it's, yeah, I blew up one when I got a little fast and loose with my offsets, trying to see how close to the bottom of the hole I could get. When you hit the bottom of the hole, everything explodes. So I changed some of the machining tolerances a little bit to make that easier for myself. But yeah, I went through the entire run with no issue. Once again, like 10 times faster than I normally could. So that's awesome, because now that's another area or another element of the design that I can scale a lot easier. If my mill had a tapping head, that's something that now can be totally automated. So basically, before I run anything through production, like switching to these form taps, for instance, I tapped a piece, one of the caps here, it's just kind of a scrap one, if I can get it in focus. Basically, I machine all the parts, and then I cut the section out with a little saw there, just so I could basically examine the threads and see what they look like. And since these are formed threads, they're essentially work hardened or like cold worked, you get a very, very strong thread. At this size, is thread strength an issue? Probably not, because the fastener is so small. By the time you put enough force to snap the screw or pull threads or whatnot, you're going to be rounding out that fastener way before. But nonetheless, I still put a screw in here and basically tightened it as tight as I humanly possibly could until actually it's the drive on the screw failed first. So that basically makes me pretty confident that the threads are never going to fail. And I think they're a lot stronger than my old cut threads. So I'm happy with them. That's what running on these new pens, and they came out primo. Now I know someone out there is yelling at the screen just saying, thread mill it. You have a CNC, just thread mill the holes. And thread milling is definitely something I'm going to do. But a 256 size thread mill is very small and quite expensive. So while I definitely am going to experiment with it and see how it works out, it's not something I want to rely on for production. Because it just, same thing, it just amps the stress level up of trying to make something work if you're not completely comfortable with it yet. So of course it's something I'm going to play with, but it's just nice to have a fallback on something that I know is reliable. And so far, form tapping, big fan. And to round out my story, basically we have a run of these that should be, I'm pushing hard to basically have these ready for Friday. I think Friday is going to be a little optimistic. So I think it's probably going to be next week that these will be ready on the site. Stainless, titanium. These, if you can see, are actually a little bit bigger. Let's go closer so you're not just looking at my face. They're a little bit bigger than these are the minis. These ones are a little bit larger. That's because they are sized to take the they'll ship with the Easy Flow 9000 refill, but they'll fit any Parker style. So if you want to use a space pen with a little plastic bit or any other Parker style refill, they'll all fit in this body. So that's why I did that. A lot of people requested that. So this whole run will fit these, which is going to be awesome. I also was able to sneak a few of these in. These are full titanium body, tips, everything. Actually, well, the screw is technically still stainless until I make or buy little titanium ones for those. But this is a full titanium body, one of 3, the first 3 I've ever made, and unfortunately I don't think they'll be for sale. They're gonna go to some of my beta testers. I say that with quotes because they're probably just gonna go to friends and family. I'm not completely happy with it. I didn't have the internal reamed diameter, so these are drilled to a 1/4 inch, and I drilled from both sides to try to make life easier on myself. So there's like the slightest ridge that you could feel if you, for some reason, slid like a 1/4 inch dowel pin through it. Anyways, just not something I'm super happy with as a production unit yet, and they take a buttload of work. So it's something I'm working on. Deep drilling titanium is not easy. So I got all kinds of weird harebrained things. I had this weird idea to basically make my own coolant through drill. I could put a through coolant drill in here. This screwed into my tailstock, and I would plumb in coolant lines here. But running a carbide drill in my little tag lathe might not be the best idea. I don't think it has the rigidity. I think it's going to explode, and those drill bits aren't cheap. So that might wait for another day. But lots of different ideas. Gun drills. There's a plethora of ideas I'm chasing down. I mean, I could buy a tube that's the correct size. I just can't find tube that I want that has the right OD and ID. So yeah, that's the update on that. But these are primo, and they'll be coming out probably next week. So yeah, if you subscribe to my wonderful newsletter thing, you'll get a notification. And if not, enjoy watching, and have a fan-frickin-tastic week, and I'll see you guys next. Bye-bye. Bye. Bye-bye. Bye-bye.